Jasvir is an advisor, technical advisor at Jasvir, a Portuguese cybersecurity startup. He has a very interesting background. He worked for Google, where he helped, or he led the Caja project. The Caja project was a project about sanitizing inputs and making sure your browser was secure. Maybe there's still some code running on Chrome from Jasvir, I don't know. Maybe that's good or not. And Jasvir will talk today about how to track down bugs. So he will share some pains that all of us probably experience, that going after bugs, then going down the rabbit hole, get distracted by a secondary bug. And so Jasvir will talk a little bit about this problem and how we can improve this process so we can track bugs in a better way. I hope I said it right. The
Yep.
stage is yours, Jasvir. Thank you.
If you didn't, it's about me.
Doesn't matter.
All right. Seeing what's wrong just right. Now, there's a perception. No, there's a perception amongst some people. It's not in this room, but there's a perception among some people that this is what a web application looks like. You type in a URL, you grab a whole application, and then you start interacting with it. And you get some HTML, you get some JavaScript, some CSS, and off you go. But we in the room know that that's not really how web applications actually are. Starting from the right-hand side, you have the website, but that website is actually interacting with a whole bunch of routers and CDNs and load balancers, and those in turn turn around and connect to servlets and databases and cloud functions, and all the way through, they're communicating with each other asynchronously. The reality is, even if you just take a web application, just a page, the page is constantly talking back to the server via XHR, via fetch, via a variety of other APIs, right? If you zoom in, even within a page, there's a whole bunch of iframes, and all of them are post messaging to each other. The frames themselves are receiving messages from each other. If you zoom in on any one of these iframes, what you find is there are all these different events that are occurring, these functions that are being called on different terms, each of them also asynchronous. And this is a great thing, right? This is a great thing because it results in performance and functionality and awesomeness as long as everything is working correctly. Sometimes things aren't working correctly. And then all of this awesomeness, all of this asynchrony is a source of nightmare, of debugging nightmare. It's a source of hell. My name is Jasvir Nagra, as has been said. I usually go by Jazz. You should call me Jazz. I've worked in web application security for a long time. I realize that some of you might have seen talks by me before, and I've never updated the slide after I hit 20 years. After 20 years, it doesn't really matter, I think. But the reason you should really... mostly I've worked in web application security. But the reason that you should really listen to me is that I, like most of you, work in web development or application development and in security. And we design and build distributed systems that we end up having to debug. And it is the case that it is extremely hard to continue to do so because the tools that we are forced to use have just not kept up with the changes that we have made in the way that we do at least web development. And I just want better tools. I want better ideas on how it is that we can make our lives easier. That's what I'm here to convince you of. In fact, I'm here to convince you of 4 things. The first thing that I want to convince you of is that web applications increasingly consist of small snippets of code, smaller and smaller snippets of code, of straight-line synchronous code that communicate with each other asynchronously. The second thing is, and this one is straightforward, that humans mostly think synchronously and serially. The third is that there's a gap between these two, and I'm going to give you a series of tips and tricks that you can use to bridge this gap. But mostly, I want to convince us that a larger effort is needed in order to raise up the level of debugging ability that we have. And I'm going to try to convince you of one idea, maybe not convince, but suggest one idea, one approach that we could be taking to change the way in which we do debugging. This is a fairly early tool that I'm going to be showing you, and mostly what I'm trying to do is solicit feedback on how one should be doing this kind of thing. I know you came here to see me give you information. What it turns out is I'm actually here to beg for help. All right, so in order to motivate this, I'm going to give you 3 little bugs. Actually, until 5 minutes ago, I had an off by 1 error. I thought that I had 4 bugs to share. Apparently not. These little bugs are actual production examples of code that I have seen running that were very difficult to debug. Whilst I go through them, I want you to be thinking of 2 things in your head. One is, have I experienced bugs like this before? Or is Jazz just pulling my leg, he's just making this up? And the second is, if you experience bugs like this, how would you go about debugging and solving these bugs? All of these bugs have performance, security, and functionality implications. All right, the first one is a Heisenberg, named after Heisenberg, I guess, but not this one. But you have to admit, Walter White is a lot more dramatic than Werner Heisenberg ever was. A Heisenberg is a bug that changes its behavior as soon as you start to observe it. Oh, by the way, there's a bunch of interactive parts to this, so if you don't like that, sorry, too late, don't go. All right, here we go. So this is a bug, this may be a bug. What is wrong with this function? And if any of you say the indentation is wrong, I will lynch you.
It's JavaScript. That's what's wrong.
It's JavaScript, that's what's wrong? Yeah. Okay. Specifically, does alert ever fire in this particular case? How many of you think yes? No. How many of you think no? How many of you think maybe? Well, I've run out of options. All right. How would you find out? That's the question. How would you find out? Actually, how would you find out? You just run it. And if you run it, I'll tell you what happens. Sometimes it runs, and sometimes it doesn't. So you're all right. But when it doesn't, why doesn't it run? And how would you go about finding out why it doesn't run? Well, I assert that most programmers would end up inserting the equivalent of printf. Are there printf debuggers? 1, 2, 3, 4, 5, yeah, the rest of you are liars. Are there actual debuggers? People that use actual debuggers? Okay. How many of you rely on divine intervention? Most of you. Alright. Okay. So let's try it. Why don't we try it? Can I run this thing? Here we go. Okay. This is the code. It's the same piece of code that I inserted before. And edited because I'm advertising OWASP Lisboa. Why not? I'll add that. And I'm going to hit reload on the page. And reload this page. And no alert. So everybody that said no alert, you win. But we want an alert. Okay, so let's try to debug it. So we go open the developer tools. Alrighty, now we reload this page again. Oh, let's remove that piece. And now we reload this page. And it runs! What did I change?
The instrumentation?
Do you want me to run it again? Oh.
No.
Sorry, that was bad. Alright, reload.
We are instrumenting the code.
Am I instrumenting? No, I should not be instrumenting.
You didn't use the main.
Oh, yeah, that's true. Okay, that's not what happened. the act of opening the debugger changes the behavior of the application. And there's a little sneaky thing that I'm doing there, which some of you might have noticed. I'm actually loading the entire page slowly, and as soon as I load it slowly, what ends up happening is that the load event of the entire page is delayed. But one does not need to do that. Funny about this. The question is, how would you end up trying to debug something like this, where the act of debugging changes the application? And this was, in a larger complex application, really difficult, because as soon as you start to single step through an application, the behavior of the application changed. And I'm going to suggest one way in which we go about doing this. One way in which we go about doing this, whenever people say, should I use console log or should I use the debugger? This is like asking, do you want chocolate or do you want ice cream? And the cheap answer is always use both of them, right? But like in this particular case, it's not just use both of them. The behavioral change that you're getting as a result of there being a difference between the debugging behavior and the non-debugging behavior is what allows you to differentiate the two lines of debugging. So if you have console.logs scattered throughout and you run them with the debugger closed and the debugger open, then what you are able to do is where there is a divergence in the trace, where these two traces differ from each other, is probably where the root cause is. The other thing is to be aware that the debugger can change behavior. And this seems intuitively possible, right? Because the way the debugger does not stop the world, it stops one thread of execution, which means that other things are continuing to execute. Don't let me imply that that I have anything poor to say about the Chrome debugger. It's one of the most awesome widely available debuggers that I know of. Do I have time? I want to show you something. This is going to be very disappointing if this is the thing that you end up remembering. But this is something that I'm sure none of you know of, and it's one of the most amazing things about the debugger. So I'm going to open the debugger. This is the debugger. But guess what? The debugger is just another HTML application, which means that I can open the debugger for the debugger. Right? So I can go ahead and say, open the debugger for this guy, and this guy, this is in Inception, right? This second window is now debugging the debugger, which is debugging the main window. If you don't believe me, here, this guy selects an element. All right, let's select, let's not do that. Let's switch over to sources, say. And I want to select, let's say, this one here. Yep. So that's pretty amazing, right? Not only that, watch this. Sorry, this is going to make me run over time. So I can. So that's the guy. I can click on that. I can click mouse down on that element that I just selected. Which means that you can programmatically change the Chrome Developer Tools debugger. It's never something I've done. It's something that is worth thinking about at some point. Anyway, back to the serious stuff. Alright, where were we? Oh, one other thing. So, I asserted that part of the problem with the debugger is that a debugger stops one line of execution, but other events are continuing to occur. One of my friends, she came up with a technique that she calls alert debugger. Don't ask me how it works, but if it is the case that you want to actually stop the world across the entire set of events, if you do an alert, then open the debugger window, then fire the two debuggers, you actually do stop every other execution, which means that you can actually stop the world and do debugging. Is it a trick you want to use? Probably not, but it's there. If you want to know more such tricks, come up me up. Alright, the other case that asynchrony brings to you is when we have asynchronous requests. Here's another bug. This one looks a little bit more contrived, but believe me, it was a distilled version of real code. What do we have here? We have some seed that is being set. A compute seed JS is loaded onto the page. Presumably it sets seed. Then document.cookie is set to that seed. Then fetch is sent, and because credential same origin, which is default, but credential same origin suggests that that cookie is going to be sent along to login status. Anything that can go wrong there?
When I set the cookie as the code run, did I generate something, or do I have seed?
Well, you should just assume that seed, that this seed was set by compute seed when it was loaded. Anybody? Fetch is another one of the. Fetch is an XHR, but cleaned up. All right. Well, the bug here is that I'm lying to you, right? And you should get used to that. So what is happening here is this appears to be straight line code. This appears to be like this is going to run, and this is going to happen, and this is going to happen. But what is actually happening is a pen child is going to cause compute seed to be scheduled for executions. And then document.cookie is set immediately after this, or sometimes it executes in time, sometimes not. And then presumably sometime later fetch is scheduled, but it's possible that fetch happens before this guy happens. The only thing that you're guaranteed is that document.cookie is set before the fetch is called. Now, don't worry about the details. The question is, how do you know? How do you come to find out that this code is broken this way? Right? And it's, well, one of the things that Chrome DevTools gives you is this ability to see the network requests. Right? So you can see all of the network requests, and you can find out what is actually happening. So the network request tab gives you who requested a request, what the request response headers look like, and what the sent and set cookies were. But what you often want to know when a network request is made is other parts of the state of the application. How am I doing on time? But what is missing is the state of the application. But the thing is, you can tip to improve that is one of the things you can do is add cookies and set cookies to the network requests so that at a glance you can see what is happening. But more importantly, you can add custom headers with information that you are trying to remember at the point at which a request is being made. Fetch takes an extra set of headers, and attaching these means that when you are trying to do some debugging, you know exactly where an application is at. Okay, this third one is the curious case of postmessage. Postmessage. What is postmessage? It is a way of transferring mostly safely, mostly JSON-like objects. There's some extra stuff you can do between two different origins. Postmessage happens to be my favorite function. Everybody has a favorite function. This one is mine. What it allows you to do is send a post message, send some data across the same origin barrier. So browsers have the same origin. You can't directly communicate with things on a different origin. Post message allows you to send messages on the other side. On the receiving end, what you get is the origin, which is the URL of the cross origin that's sending you something. Essentially a reference to that thing, and then the actual data. Why is this a problem? Well, sometimes when you're in iframe, you're getting content from all kinds of places, and what you want to find out is who is sending me this data. And usually what you do is you end up checking the origin against the origin you're expecting to receive a message from. The problem is that there might be multiple iframes that have the same URL. And so it becomes difficult to check that. And what you end up having to do is actually cross-check the source. But the security gets in the way, and whilst you're debugging, in many cases, you end up not actually being able to introspect on that reference. Don't worry about exactly what I'm saying there, but essentially it means that occasionally a post message is sent and it is never received, and debugging becomes difficult in that case. Now, there's two little tricks that you can use here. One is, I find it very useful to just attach a debugging on-message handler inside every iframe that is created. What you end up with is a large amount of noise. If all that you're doing is logging, Chrome also has a monitor events thing, which allows you to monitor all of the messages that are being sent of a particular style. Okay, this gets noisy pretty quickly, and you end up grabbing through a lot. What am I trying to say here? I gave you 3 different examples, and we couldn't hobble through, right? I mean, it was like, oh yeah, I can do this little trick, I can do this other trick, and I can make sure that I sort of understand the debugging problem that I have. For one case, I had to do it one way. For the second case, I had to go look at the network tab. For the third case, I sort of flubbed my way through. The problem that we have is that all of these processes are ad hoc. There's no systematic way in which one goes about understanding how all of these different parts of my program are working. My suggestion is to have a programmer's cockpit. One place where you can lean back and see all of the ways in which the different parts of my program are running. I end up calling it the programmer's cockpit, or Peacock. I've seen a lot of peacocks while I've been here in Portugal, and it's been amazing. This is like reminding me that I should really work on this more. So, what are the properties that I need? I need to collect all of the APIs and all of the arguments that are being passed to it. And then, as you are debugging, you learn new things, some things that the program does not know, but you know, oh, this business logic means that this thing is never going to occur. A human or a security researcher continues to add to this database constraints on what can and cannot occur. Then you want to be able to query this database in some understandable way to see what things are true and what things we need to look at more. And then finally, we want to be able to see what is happening, visually see what the landscape looks like. Like I said, we want a programmer's cockpit where you can sit back and really see the execution space of your program. So in order to do this, what do I need? Well, I need to see all of the program state. I need to see all the reads and writes. How do I do that? Well, actually, in order to see all the reads and writes, that sounds like a really complicated program, but if you squint right, we actually don't need to see all of the reads and writes. We really just need to see how the reads and writes are occurring between asynchronous components. And in order to do that, that just needs us to understand what DOM APIs and JS APIs are being called. So if I get that one, I have this one. The other thing I will need to know is how components are interacting with each other. Again, the only way to do that, or the only thing that you need in order to do that is DOM APIs and JS APIs. So really, if I get that guy, if I get the DOM and JS APIs, I'm good to go. Are we happy so far? All right, we're on the fence. How do we do this? Now, those of you that know me know that I only have really 2 or 3 tricks in my tool bag, and one of those tricks is virtualization. What is virtualization? It means that you end up replacing a DOM API with an equivalent DOM API that actually executes the same way as before, has the same signature, but does one little bit extra. This allows us to intercept all of the calls that an application makes, allows us to optionally change the inputs and outputs, maybe even prevent the original function from being called at all. Now, those of you that have tried to do this kind of thing know that in order to do this fully, well, I'm kind of hot. For debugging, if you want to do this fully, it's really hard to do. But for debugging purposes, a poor man's version or poor person's version suffices. So this is what a poor person's version of virtualization looks like. It's very simple. You take the original version, in this particular case, document.createElement, and then you replace the original guy with a new function, which just calls log of that function, like this function is occurred, and then you apply the original, which means you just run the original as it was. And now when you call document.createElement script, it runs exactly as before, but in addition it's calling this log, and where is this log going? It's streaming into some database. Good? All right. There's some challenges that comes with this. If you know top.location and document.location actually are frozen and they're not virtualizable, it's horrible. And if you want to do those, There's a lot more work that you need to do. Don't worry about it. It just occurs a lot. The other one is post message. I told you that post message is my favorite function. Post message is one of these very magical functions, and one of the magical things about it is that it's the only function in the browser that you can call cross-origin, right? And if there are like security researchers in the room, I don't think that that's been tried out enough. But one of the things that happens is that if you replace post message, the magic goes away. The browser just says, you're trying to replace post message. I'm going to take the magical property of it, that it is callable cross-origin, and that I'm passing you this event source. I'm going to take that away from you. But both of these are a little bit hard to get around. Let's forget about them. Now we have all of these functions going, all of these events going into a database. So, but now we can query the database. And I asked my database friends, well, how do I query this? And they're like, dude, there's this thing called SQL. It's amazing. And so this is what I wrote in order to find out how many post message and receipts have occurred. Now, this was horrible to write. I'm sure it's even worse to read. And guess what? The magical property of this is that it's wrong. I got it wrong too. So we need a better way of writing pattern matching systems. And I know half of you are here for exactly the next slide, which is, I went with Prolog. Now, Prolog was a language invented in the 1970s to write AI programs and torture undergrads. Any of you have been tortured by Prolog before? Yeah, this is how, if you look around the room, these are the old people in the room. I'm sorry, and a very young lady there. Okay, but the parts of Prolog that we need are actually not that complicated. I took care of all the hard parts. Now, if you don't know Prolog, I'm going to give you a 3-second introduction to Prolog. 1-minute introduction to Prolog. Here's 2 or 3 facts that you need to know. Number 1, if a Prolog variable name starts with a lowercase letter, it's actually a constant. Right? If it starts with a capital letter, it's actually a variable. And if it's an underscore, it's ignored. Okay? Good. The next thing is, you need an expression, and it's separated by this half smiley face, colon dash. And what it does is, whenever you write this, Prolog will go through a process called unification, and it tries to find values to fill this variable with that mean that the right hand side and the left hand side mean the same thing. If there are mathematicians in the room, they'll be very horrified by what I've just said. But essentially, that's true. Then I'm going to go through this example. Right? What does this say? This says that Luke's father is Vader. Oh, spoiler alert! It's Luke. And then Ben's father is Luke. Okay, so far, so good. Yeah. And then, what is a grandfather? Oh, what is a grandpa? Well, a child's grandpa is a man if the child's father is some guy named Dad, and that dad's father is that man. Okay, I'll let you process that for a second. Yeah, it seems obvious, right? A child's grandpa is some man, as long as his dad's dad is that guy. Okay, and now you can ask, hey, Prolog, who is Ben's grandfather? And Prolog churns through its database of facts, and it comes back and says, who is Vader? Vader is his father, is his grandfather. Okay? Cool. Are we happy? Are we sad? Alright, so applying Prolog to the program. So, virtualization lets us intercept all the DOM APIs. We stream these DOM API calls and metadata into this Prolog database. If we collect everything as it happens, we can query it. And this is the thing that I was streaming. It looks more complicated than it is. All that I say is every time a post message occurs, it happened that a post message occurred, and it sent the message hi, and it would have gone to anybody. Right? And then some metadata like what the iframe thing was, what that ID was, maybe the start and end time. Who cares? Now, remember that SQL statement? This is why I went with Prolog. Now I can write this other thing, and you don't have to write it, I've written it. Post messages are whatever happened when there's a post message, and then some other stuff. And so now I can ask, hey, what are all the post messages that occurred? Database. And post messages, the database comes back and says, oh, there was a post message of ABCD, and it could have been sent to anyone. There was a post message of hello, could have been sent to anyone. And there was a message called Samtran, and it was only be receivable by receiver dot. All right, this is kind of cool, right? This is pretty neat. Okay, now I can ask even more interesting questions. Hey, do we have any post messages that we sent, but they were never received? Okay, how about that? Well, for all post messages, was there any that was not got a corresponding on message? Okay, and it comes back and says true. Ah, there's a bug. We know there's a bug because we sent a post message. Presumably it wanted to be received somewhere. It was never received somewhere. Okay? What's the next thing we do? Which message was it? Okay, this one is a little bit more complicated looking, but it actually is not really so bad. All it says is, of all of the post messages, if I take out all of the ones that received an on message, what is the thing that is missing? What is the thing that is remaining? The database comes back and says, missing, A, B, C, D. And now you know, okay, somewhere I sent an A, B, C, D, and it wasn't received. Handy, right? Now you can think of all kinds of things that you can do now. You can find functionality bugs of this sort. You can also find really hard to find performance bugs. I had a customer who had a scroll bar that every once in a while would slow down a lot. That's a really hard bug to debug. Because if you open the debugger, the problem goes away. If you stop, problem goes away. It's a really hard bug to debug. But now you can ask the database, hey database, what is the most common function that is somewhere on the stack whenever the time between two scroll events becomes bigger than some number? If it becomes bigger than some number, it's scrolling slowly. Okay? And then it comes back and it says, yep, document.cookie gets set. Oh, document.cookie, if some of you know, is a pretty slow operation. If it happens every time you are scrolling, which is what was happening, it slows down the scroll. So it's pretty straightforward. It was like one line. It comes back and it tells. There's a bunch of security people in this room. I'm not going to tell you the kinds of security bugs that you can find. I'm going to leave that to your imagination. I used to be a professor, so this is like homework exercise. But I'll whet your appetite just a little. You can imagine a whole bunch of cases where you read user input from somewhere, and it flows to some XSS sink, and nowhere on that path is there sanitizer. That seems like it would be an XSS, right? It would be an interesting way to find XSSs. Alright, onwards. It's not enough. It's not enough to have a database of types. Human beings are not just synchronous, they're also visual creatures. If you want to get like an overall sense of the flow. Another friend of mine helped write this for me. I could not do graphics very well, but there's a graphics library called D3. And this is some function. I did write the function. Just look for the most complicated function I could write. And then you run this for a little while, and now it pumps all kinds of events into the database. And then you say, okay, visualize the database for me. And now what this tells you is that, hey, post message causes set timeouts, causes document.location.read. Set timeout asynchronously causes send XHR. Post message also asynchronously causes one message, and so on and so on. But the thing to note about this is, unlike, hey, a series of events occurred, what you get here is causally related events. This event caused this other event. There's much nicer off-the-shelf visualizers that are used for a variety of things that one could adapt into this. Open Tracing is such a library, Zipkin is such a library. They're mostly used for timing, but if adapted so that events from this database get pumped into that visualizer, you get very beautiful pictures. I found another one that visualizes promise trees, even more powerful things. And again, it's the causal relationship, which is actually what you want to know when you are trying to debug your program. Ultimately, what we're aiming for is a holistic view of the world, of our world. And what this approach allows us to do is to stitch together the fragmented world of asynchrony back into a cohesive world. And that is the vision that I have with Programmer's Cockpit and restoring debuggability to asynchronous programs. Thank you.